doing this code for C. We are going to look through linked lists in C programming, and we're going to try a few functions. So basically, I'm going to import these two libraries that we have there, which is Studio H and Studio lib.h, so that I can run my code very well. So we're going to introduce two variables, one called number, and we are going to also introduce a structure called node, and we also place a pointer. So from here, I'm going to introduce my main function, int main, and from here, I'm going to bring about the structure, and then we use this head pointer and set it to null. So this first point of main is going to be for the list, and the list itself, when I've created it with the head as its pointer, I will set it to null as a means of showing that it hasn't yet had anything to be stored inside. So I'm going to introduce more variables called choice, data, key, and value. From here, I am going to look through the functions that I'm going to use. So I will print them in the order I want them to be printed out. And through these ones that I'm printing out, I'm going to allow a user to choose within them. So the choice they will make will be kept in this register called choice, and that is what I'm going to use. So using the switch function, I'm going to allow my user to be able to choose within the cases that I have here. So for case 1, which is to print the list, it should be able to print whatever is in the contents of the list that I have here. So using this function for head, it will print out all the values of head that we have, actually within the list that we have, not inside the head. So if I choose case 2, the user will be able to append data within that list, and the data that they will input. This scanf program will prompt the user to type in the data, and the data will be stored inside the register called data. So when I'm appending, the data that was stored in here will be taken and placed inside the head, which was the structure for which we had placed for our list. Thank you. So now from here, we shall go to case 3, and we have the prepend function. So inside the prepend, so when it comes to prepending adds the integer that you want, or the function itself, to place it at the beginning of the list. When you append adds whatever you're adding. Right now, the structure that I've created is mainly for registering integers. So if I'm to append, it will add the number that I'm adding in, the input, at the end of the list. Then if it's prepending, it will place it at the start of the list. So we shall have case 4. Case 4 here, we shall have function. I'm going to call on the function to delete by key. And then for case 5, I'll be able to delete by value. I'm going to explain this later on while we are going through the program. Then for case 6, I'm going to use the insert by key, which means within the list, a person is going to be able to insert within the list that I have after a specific key, and also inserting by value, someone will be able to insert after a specific value. I'll explain this more while we are running through the code. Then for case 8 will be exiting the program. Remember, since I'm using a while loop up here, this while loop here, my program is going to be able to continuously run until I finally call it to exit. So for case 8, after running your program and you are done with everything that you have, we shall be able to press the exit. It will print for us this, then our program will exit. Thank you. So what happens in case someone chooses outside the cases? I'm going to set a default, and this default is going to print out this. In case someone chooses something outside of the cases that I've stated above, my user they will print for them an invalid trace, and they will request them to try again. So now to explain these definitions we have here. First of all, I'm going to create our list, our linked list. Why is it called a linked list? Basically, when you're writing lists, we are usually when it comes to C programming and you're writing lists, you're supposed to state the number of items you expect to be within that list. But when it comes to linked lists, here someone can keep on adding and subtracting within the list that is given, regardless of the people that are there. Now we are imagining we are registering students and we do not know how many we shall have. Using linked lists would be the best option. So here I'm going to create my structure and I'm going to create a node and I'm going to use this create node function. So when I create this node, I'm going to introduce an integer called num. So inside our structure, I'm going to come and say our new node is going to be equals to the structure node here. And this is a memory allocator. This is the malloc function, which checks for the size to see if there are addresses within that are left within our list. And that's what I remember. So now we are going to bring in this condition. We shall say if our new node, if the new node, this is the first case, if the new node, this is a pointer, points to a number, we shall say the number is equals to num. But if the new node is equals to next, if it is pointing to another pointer, which would be an address, we shall say it is pointing to num. Now, we shall return our new node, just in case. So how should I explain this better? If somebody inserts a number, this new node that we have created will be set to the number, and the number will be equals to the number that we have input. So this is the user input. And then this is the number, the address we have created at the beginning of the program. So we shall create another new node, and this new node of ours will be assigned the next address. This is an address, and this address will be set to now. Thank you. So from here, I'm going to create a print list function, and this print list function will come and pick from our struct node, and it will print out this. Actually, it's printing out this function of ours, this. So whatever contents we shall have within our struct node head, which is basically the linked list, will be printed out by this function of ours. So if our head is equals to now, we are just imagining someone has not yet input any data. The list, our function will print out that the list is empty. In case we have some items within, it will come and get the current inputs or the current addresses, the current values within our function, and then it will print them after this. So where the current is not equals to now, our print will get the current and the number, and then the current, okay, it will print them, it will print the current number and the numbers after the current number. Then after that, it will skip a line and return our value. In case someone decides to append within our linked list, what would happen? So this is the code for appending. Here we shall get our struct node. We shall call onto our function and our new node. Now it will create a new node, which is num. It's important to use the same the same variables to prevent confusion. Anyway, so we shall hold on to this now, and then inside our head, we shall return a new node. A new node. Now this new node will be for this value that we have. So this value will be placed inside the node that comes after the next one. So from here, we shall say well the node it will basically create the new number inside, and then it will set the current address to next, and then the next will be set to the new node. Now remember, our new node was set to null. Now with the null, it means it can keep on adding on after the new node that we have, the current new node we have. So we shall say we are going to prepend. So prepending allows someone to add before, at the beginning of the list. Even when you look at it here, they'll tell us that we shall call onto our function again, and then we shall create a new node now. Now, in our new node, we shall have the next, then we shall call onto the head. So the head will be placed in the new node, which means the value that we are placing will be placed at the front, then whatever comes in the list that is currently available will be pushed to the address that comes after that. So that is how you prepend. It basically puts the value after. Okay, at the start of the list. So now we are going to talk about deleting by key. So deleting by key, we shall call on to, if we have our head and we set it to null, it will actually, if you try to delete something within the list that already does not exist, if you should place some sort of item to show that the key that we have inside here does not exist. So when it comes to the deleting by key, it will come and delete whatever is inside, then it will push the items that you've deleted by and push them to the address to replace what you've deleted. So when it comes to the deleting by value and the delete by key, deleting by value works in the same way, but the difference comes when you are deleting. So by value, deleting by value means you're deleting the contents within the node. Then when you're deleting by key, you're deleting the node itself. That is simple way of putting it across. And usually the node itself, the name of the node is usually given by the content inside. So when we are deleting by value, let me see the numbers, it will be more explanatory when we are trying it out. You will see it that if I'm to delete the number within our list we have inside there, deleting using that very number we have can usually delete it. So they are the same, but the way they operate is different. So same goes with the insert after key and the insert after value. So when you're inserting after a key, it means you're inserting after the node. And if you're inserting after the value, it means you're inserting after the contents inside the node. So let's try out the program. So some of these things are best explained by the program running itself. Okay, the program started. Okay. So now I'm going to start my choice. I'm imagining someone is trying to print the list, but they haven't yet inserted any items. So when you press 1, it will tell us that our list is empty. So I'm going to try again. And we say I'm going to put some values within our list. So we shall say I'm going to use 2-digit numbers to prevent confusion. So I will say I'm going to start with 12. And now I'm appending, and if I try to print my list, it will print for us 12. So realize here our list has 12 inside. So let me try to prepend. I'm going to use 3 and I'm going to prepend 13. So if I print out my list, you realize we have 13 and 12 inside within the list. So from here, I'm going to decide to, let me add in some few other numbers. Okay, so now let me print my current list. My current list has 13, 12, 14, and 15. Yes. So now I'm going to try out the delete by key. So when we delete by key, we are going to choose onto this list we have. The keys, remember, are the nodes that contain the address, that contain the integer. So to call them, I will call 14. That is the node. And now if I decide to print out the list, you realize that 14 has been taken out. So if I'm to delete by value, say 5, I'm going to delete 13 because it's making my list bad. I'm going to delete 13, the value itself. If I print out my list, you realize that we have 12 and 15 remaining. So now I'm going to insert. I want to insert 13 after 12. So I'll say the key after which to insert 12, the value to insert 13. Now let me print my list. It comes out like this. We have 12, 13, and 15 in our list right now. So I'm going to decide to insert after a value. So inserting after a value, we shall say that is option number 7. So the value after which to insert would be 13. The value itself is 14. If I print the list again, you'll get our list. Now this is our current list again, which is 12, 13, 14, and 15. So from there, we shall decide. We are done with this. We have heard of duplicates. Let me try to write another. Let me try inserting another one. Now I'm going to insert. I'm going to append. I'm going to append, and I'm going to append a 13 at the end of the list. So if I print out my list, you shall realize we have 13, both after 12 and after 15. So now I would like to show you something interesting. When you delete by key, let me say using the 4th option, and we delete 13, and we print out our list, you realize that it chooses the first occurrence of 13 to delete. So basically, when you're deleting by key or deleting by value, or even the same case with inserting after the key or inserting after the value, they usually insert after the first occurrence, or they delete the first occurrence of a number that you have. So I'm going to exit from my program, and here my program has closed itself automatically. Thank you very much. I hope the things